Hello.
Yes, sir. Yes, sir.
Good afternoon, everyone. Thanks for joining us in afternoon session. Myself, Vishwas Karhadkar, Assistant Professor, Computer Science and Engineering Department, Mahakal Institute of Technology, Ujjain. I welcome you all on behalf of Mahakal Institute of Technology in today's second session of recent innovative techniques in cyber security organized by Rajiv Gandhi Pradhyogiki Vishwavidyalay, TEQIP 3 Bhopal. Our today's second session eminent speaker is Dr. Nilesh Kumar Jain, sir, Assistant Professor, Senior Grade, Computer Science and Engineering Department, JP University of Engineering and Technology, Guna. Dr. Nilesh Kumar Jain did his PhD in 2018 from JP University of Engineering and Technology in the Department of Computer Science and Engineering. The title of his research was Efficient Approaches for Digital Image Forgery Detection. He received M.Tech in Engineering System in 2006 from Dayal Bagh Education Institute, Agra, and Bachelor degree in Information Technology in 2003 from Dr. B.R. Ambedkar University, Agra. He has been recipient of Director's Gold Medal of Dayal Bagh Educational Institute in M.Tech. He has 13 years of teaching experience for PG and UG courses of computer science and engineering. He has published many research papers in reputed international journals and conferences, including SCI Index journals. Now, I request Dr. Nilesh Kumar Jain sir to start the session with your beneficial words. It would be great pleasure for us to start the session without taking much more time. Over to you, sir. Sir, am I audible? Nilesh sir, am I audible? Nilesh sir, am I audible? Nilesh sir, am I audible? Hello, Nilesh sir. Nilesh sir, am I audible? Over to you, sir. Nilesh sir. Nilesh sir, am I audible?
Hello.
Sir, over to you, sir.
Hello, sir. My voice is coming, sir?
Yes, sir. Yes, sir.
Oh, okay. Sorry, sir, for delay. Actually, some technical problem is going on. That's why I was not, my voice is not visible here, audible to you. So, may I start, sir?
Yes, sir. Do me.
Okay, okay, sir. So, good evening, everyone present all here. Myself, Dr. Nilesh Kumar Jain, and thanks to Vishwas sir to give me opportunity to discuss about digital image forensics. So first I start with why digital image forensics is related to how the digital image forensics is related to a cyber security field. Actually, we need to understand that in cyber security field, the attacker try to attack on your authorized information with the help of some passwords and knowing information. So he trying to access your authorized information with the help of unauthorized access. What happened in the today digital media? We people are heavily rely on the digital in which we are communicated through various social sites, media and mobile phone. So what happened, whatever we receives, and by seeing that image, we are believing that the information represented by that image is correct, and based on the information received from the image, we are doing something and we are thinking something else. So in that case, if the image is manipulated, if someone is hide some irrelevant information in that image, which is not relevant basically, because that image is unauthorized or unauthentic image, and they send to you, and by seeing that image, we people mislead to some information. So this is the attack in which you itself are attacker basically. So we need to understand that how that image gets forged and how you can identify that particular image fall in the category of authentic image and in the false or forged image. So the digital image forensics is a new research field of the cyber security, in which we need to authentic the authenticity of the image by doing some ballistic set of operation. So first we need to understand actually whatever I discuss in the digital image forensics field, you people may get a new idea of research, because this is a new research field in the dimensions of the image processing, and there is a lots of scope also. So I will explain one example also how we can think for a new algorithm in the field of digital image forensic, and how we can perform the operation basically. So the motivation behind to study the digital image forensic, and we need to go in deeper in this field, because in digital age, everyone is rely on the photos, and lots of hundreds of and thousands of images are circulated through our digital media. So if anyone is get manipulate this image with the help of any software tool, they will mislead us basically. So at present, people are facing image forgeries in many real-time applications such as court, data of financial, legal evidence, medical reports, high-value assets. Even in scientific literature also, there is a image forgeries at is present. And if you are considering one real example, if we want to purchase some house, so people showing a one graphical generated image to us and said that the house will be built is exact replica of that image, but it didn't happen in the realization. So such type of image forgery will lead to a attacker. So basically, all of these factors motivate us to design a novel framework for a detection of image and distinguish between which one is a forgery image and which one is the authentic image. Now, first we need to understand what we mean by digital image forensic. So image forensic is a well-developed field that analyzes the images of specific condition to build up trust and genuineness. Basically, image forgery implies altering the digital image to some meaningful or valuable data. For example, we have seen various images. The people attached themselves with a famous personality and said claim that he I personally get met with this personality. So by splicing the two different image in a single frame, they will mislead to the pupil. So such type of image we seen in the literatures also, or in the newspaper and digital media also. So basically, two principal area are evolved in the name of digital image forensic. Before do the forensic in image, we need to understand the source of image generation. So we know very well the image is captured by a camera. So that camera is known to be a source device. The source device is the one who captures the image. So one of the field or research direction in the digital image forensic is image source device identification technique. If we people are able to identify which device capture the image, your work become very easier to identify the attack on that particular image. And if you people are not able to identify which device is captured the image, instead of this, we people try to identify which device did not capture it. So basically, we are trying to identify which device is capture it, and why we need to focus on that, because every device is having the unique editing signature which is embedded in the image at the final outcome. If you capture the image through different form, if you see the format of that image in the background, you will find the specific editing signature is get added by that particular device on that particular image. So if you are knowing the device X capture the image Y, and if you want to do some ballistic set of operation on that image, you can do very easily because you know very well what type of signature must be represented by that image. So this is one of the field by which you can identify whether that image is undergone attack or not. And the second technique is that in which there is no need to know which device is captured the image. Basically, this is the second group of method. What we did in this group of methods, we are doing the semantic manipulation. Why? Incons- by studying inconsistency in natural image statics. Actually, every image, the digital image is a combination of pixel, and each pixel is represented by the set of binary bits. So by identifying the correlation between these binary bits, maybe in pixel intensity, correlation between the pixel intensity, correlation between the histogram, correlation between the RMSE, correlation between the standard deviation of the each particular part of the image. So there are various methods by identifying the relation between
Sir, sorry
these.
to interrupt. Your PPT is not shown.
No, my PPT is not visible.
Yes, your PPT is not visible.
Okay, sorry, sir. I am doing again. Okay.
सर आप उसको पिन कर दीजिए आपके जो पीपीटी ना
उसको
उसके ऊपर पिन कर दीजिए उसके ऊपर. Yes, sir.
now it is visible, sir.
Yes, sir.
Okay. Okay, now it is visible to you, sir. Hello.
Yes, sir. Yes, sir.
Oh,
Yes.
okay. So I am discussing about there is a two principal research direction in the field of image forensic. One is the image source device identification, and second one is known as the image tampering detection technique. In the first part, sometimes is known as the active type of forensic technique, in which we need to know the history of the image, means which device is captured the image. If we know this source of generation of the image, and then it is very easy to identify the attack on an image. Whereas in the case of second group of methods, we need not to be know about the history of the image. We just analyze the intrinsic information of the images, find a relation between the different information which we extract from the image, and try to identify the attack on that particular images. Now, so again, there is a two active field in the image forensic. One is known as active image forensic. Second one is known as the passive forensic approaches. First, we discuss the active approach, and many times that active approach is known as non-blind approach. Non-blind approach means in the active approach, people need to know about the history of the image, and there are two main methods: digital watermarking and digital signature. Basically, what we did in this approach, we add digital watermark or digital signature inside the image, if and we send that image to a third party. Third party exactly know that digital mark and digital signature inside the image, so he try to extract the digital mark and digital signature at the receiver side. And if this digital mark, watermark and digital signature is different from the authentic one, then they people are get the idea is something mishappening in which the people always begins their investigation by trying to finding. First they try to identify the traces of the attack, then try to identify the relationship between these traces, and the people lead to information what type of attack will have is already done on this particular image. So tampering may be a copy move, maybe a image splicing, maybe a image retouching, and maybe morphing. There is one important thing we need to know at that stage. Sometimes there is a very thin line between the malicious attack and non-malicious attack, because what happened in today's scenario, we people itself modify our image by retouching and morphing to get a better view. Nowadays most of the mobiles inbuilt with such a beautiful software, after capturing the image they will change the image in other dimension. So it basically it's an improvement your image basically. So that's called the non-malicious attack, but there is a very thin line between the malicious and non-malicious. When malicious attack is get converted into a non-malicious, Nobody knows. Image morphing, we people know in the various movies, we are seeing that the heroes get the six-pack with the help of image morphing technique. So that's called the video morphing technique. But video is a collection of the images basically. So image morphing is one of the attack or tempered on the image. Image retouching, sometimes we need to change the brightness, blurring the background. These are called in the category of image retouching. Image splicing means we combine some information image X, some information from image Y, and create a new image by combining X and Y. That is called the image splicing. And copy move is a simple attack in which the one part of the image is get copied and pasted in the image itself. So that's called the copy move attack. So this is called the active versus image passive forensic. I already discussed this one. Now, if there is an attack, then definitely there will be a tool. So there are these are some basic image forensic tools. Tools means a methods to find an attack on that image. So first we need to classify the image forgery detection technique in the various category. First one is a pixel-based image forensic detection technique, because the pixel is a basic unit of the image. Pixel is the basic unit of the image. So by identifying the relation between the different pixel of an image, we people are trying to identify the either attack is image splicing, copy move forgery, resampling, and other one. So this is the first category of the image forgery detection technique. Now the second category is the image forgery detection technique based on the format based forensics. The format based forensic means every image is having the intrinsic fingerprint in the terms of format. If we people want to see, right click on the property of the image, we can see image is a JPEG, either uh, any type of image, GIF or bitmap or anything. You will find the specific pattern of each image is having. So by seeing that pattern, we people are able to identify that image is going on JPG quantization attack, double JPG quantization attack, and JPG blocking. Basically, these are some attacks which happen during the compression, and they can change the meaning of the information also. The third type of techniques are fall in the category of camera-based image forensic. Basically, that forensic technique is if you know about the which camera captured the image, so you know what type of chromatic abbreviation is used by that camera, what type of color filter array is used by that camera, what is the camera response, and what type of sensor noise introduced by that camera, especially inside the image. So every camera is having their specific pattern. So by identifying the relationship between the chromatic abbreviation, color filter array, camera response, and sensor noise, we people are able to identify the attack on an image. So if someone doing like copy move forgery, image splicing, and resampling, so definitely these features will get changed, like color filter array property may get changed, camera response may be get changed, sensor noise may be get increased or decreased. So by identifying the pattern of these increasing or decreasing, we people are able to identify whether the attack is gone or not. Similarly, by seeing the physical environment ways, there is a two-dimensional environment, the three-dimensional environment, or light environment. What was the lighting condition during the capture of the image? So by seeing that lighting condition, we people are able to identify that image is undergone through the attack or not. And last one is the geometry base, and there is a many more type of forensic techniques are there. You can get that from various literature review. So that geometry base, if there is a change in the geometry of that image, we people are able to identify that what type of attack is going on that particular image. So this is one of the famous copy move forgery attack. This is one of the uh, picture which is claimed by that Israel. They launched the 4 missile, but actually they launched only 3 missiles. So this is a famous example of the copy move forgery in which one part of the image is get copied in that image itself. That is called the copy move forgery attack. And the copy move forgery attack detection basically classified into a 2 category. So I will discuss one by one. But before going into that one, we need to understand the digital image forgery detection technique. First, we need to identify what type of attack is going on. Second part, we need to identify which part of the image got attacked. And third part, we need to identify how much part what is the intensity. Basically intensity means whether the part of the image get scaled before pasting, whether the part of the image is scaled before pasting, whether the part of the image get rotated before pasting. So attack over attack. You are doing copy move along with some scaling, rotation, noise introduction, and other thing. So there is a two method, basic block based and key point based method. I will discuss these two methods later in the coming slide. But we need to understand block based method. We are dividing an image into a block. Key point based method. There is no need to divide an image into a block. Directly, key features are extracted from the image. Identify the relation between them and try to arrange either a lexicographical order, or we are comparing these pattern with each other and try to identify the attack. Or block based method further classified into a frequency domain, dimensionally reduction, and movement based method. Dimensionally reduction method, basically one of the famous method. What happens if we are doing the image forgery detection on the large image? The whatever feature extracted is a large number of features is extracted and generated. So with the help of this principal component analysis and singular value decomposition method, we are reduce this component to a certain level so that the processing time get reduced basically. Now this is a simple example of image splicing. I already discussed with you. The O and I are the two original images are there. What we did, the G part of that O image get considered, get combined with image I, the new image is generated S. So that's called the splicing attack. In image splicing, the two image is as an input and output image is a one. So this is one of the example where the B and C are the two new images which get combined to generate the new image. Okay, and such type of image we are seeing nowadays on a digital media, and we are believing without thinking that, because seeing is believing, because in today's scenario we are assuming that whatever is seeing, it is believing that, and image itself is considered like a thousands of words. So if someone is sent an unauthentic image to you, first we need to check their authenticity. Then digital image forensic provide a way to check the authenticity of the image. So this is one of the basic. Now this is the basic diagram who want to begin their research in the field of image forensic. I am giving a very basic idea to all of you. The detail I will give you later. Basically, how actually the image forensic happen basically. So there is a two way. Either you have the data set in which you have the forged image, or the second step you have to create a data set of the forged image. So what is the first? We have the input digital image. Forgery process may be a copy move forgery, maybe a image splicing, maybe a image retouching, maybe a image forge. Whatever forgery you want to do, please we have to do the attack on that particular image. After that, FDI means forged digital image get passed to a feature extraction process. Feature extraction process in a real life we can understand that just like a car. What are the feature of car? How much engine power it have? How much seat it have? What is the gear number of gear it have? What is the alloy wheel or not? So sometimes these are called the feature of that car. Similarly, in an image, the size of an image, the pixel intensity, the histogram, the root mean square value, and many more. How many objects are there? How many boundaries are there? So these are some features. So what we did, we input FDI, and after applying the feature extraction process, we get a feature vector. Now this feature vector may be one feature vector to one image, or a multiple feature vector depending on if you are dividing an image into a block. Now what we did, we are doing a matching of that feature vector is going on. Based on the matching of feature vector is going on, the editing signature is get generated. Now we are analyze this editing signature, and after analyzing the editing signature, we get the final result. So this is the simple process of the research direction of the copy move forgery detection. Now, more detail, what are the exact method we need to apply? So first we need to consider the input image. Now, first step is known as the pre-processing. What do you mean by pre-processing? Generally, most of the images are the colored image. So first we need to convert the RGB image into a grayscale image. And the good answer to why we need to convert the RGB image into a grayscale image, because the RGB image is having the unnecessary information which is not required during intrinsic analysis of holistic set of operation for image forensic. We need a basic information which is present in the grayscale image. So first, in a pre-processing phase, we resize the image because we need to convert an image into equal size. So resizing and conversion from RGB to grayscale, these are the two most common pre-processing operation are take place. Now there are two parts. Either you apply the block-based process or key point-based process. When we need to apply block-based, when we need to apply key point-based process, I will explain one of my hybrid method in the next one that is explained in the paper also. So after applying either block-based or key point-based process, the feature get extracted. Now whatever feature extracted, we are doing matching. After getting the result of the matching, the forgery get detected. That's it. This is the process to get a forgery detection in single image. Now the post processing came into a picture. Now post processing part is known as the machine learning part. Now what nowadays people did, they applied the various process, various neural network, machine learning activity. So they create a model, random model, and supply such type of images to them. Then that model itself classify the images into set of either forged and authentic one. So this is called the post-processing phase. Now, if I combine that algorithm into a step one, so what we need to do, divide input image into a overlapping block. This is the one basic algorithm. Anyone can implement, and providing a variation in different step can generate a new efficient algorithm. So this is the general process of the copy move forgery detection. First one is divide input image into a overlapping block. Now step number one itself provide a new set of algorithm. Either you divide into overlapping, and you may divide into a non-overlapping blocks that decided by you people. Because if you divide the input image into a non-overlapping block, definitely your program and algorithm will take a lesser time than overlapping block. And overlapping will decided by you. Overlapping by 1 pixel, overlapping by 2 pixel, 4 pixel, 8 pixel, 16 pixel, it will depend on you basically. So whatever difference you will provide in overlapping, the complexity of the system will increase depending on overlapping system. Okay. Now next one, whatever block you got, you need to apply the transformation. Basically, why we need to apply the transformation? To convert the spatial information into the frequency domain. Okay, now. So that's why we need to apply the transformation, and there are a list of transformation. The more detail I will give in a later slide. And after applying the transformation, we got the feature vector for each block. So the basic method says that suppose one image is divided into a 8 block. Identify the feature vector of the 8 block, sort that feature vector into lexicographically. Lexicography sorting technique is different from the simple sorting technique. Okay. For example, that's lexicography. Please search on that. Lexicographical sorting. What do you mean by lexicographical sorting technique? So sort the feature vector. Now, after sorting, we are trying to identify the relationship between the different feature of these blocks. And on the basis of that relationship between that feature vector of that block, we people are able to say whether that image is undergone through attack or not. Okay, which type of attack? This is the second part. First, we need to check that whether that image is got attacked or not. If attacked, then what type of attack is going on, and at which part of the image that attack is going on. Okay, now and finally we need to, that forgery get detect. So how we get a variation in the algorithm? Then you can implement that algorithm with transformation and without transformation. There are various methods which find a feature vector of an image without transformation. I will let you know that the name of this is some method. The second group of algorithm, you can generate the creation of the feature vector. So by providing the variation from step number 1, 2, 3, the different set of algorithms may be generated. And last one, there is a method of comparing the vector. So you can compare one by one. You can compare lexicographically. There is a various distance learning method also. By finding a distance between the two blocks, you can identify these blocks are same or not. So by providing a variation in the step number 5 and 6, the new set of algorithm may be generated. So which will lead to a new method basically. Basically in the research method, they are looking for a new method, which is the efficient one. And by using the different combination and permutation, we can design a new algorithm to find a forgery attack. So these are some methods by which you can identify you can extract the feature of an image without using the transformation, like that statistical analysis of pixels, singular value decomposition, PCA, intensity, and along with that paper reference is given them. You can find the detail in these papers, okay, how these methods are useful to find a feature of an image without using any transformation. Okay. Now I will discuss one problem to you. So problem description is that nowadays the copy move forgery detection become more challenging. What the method I am discussing, it is basically to find a copy move forgery attack on an image basically. Okay. So what is happening in this one? Copied region is rotated or scaled down before pasting. An image is saved in a JPG format, specifically with very low quality factor. Okay, so this is the problem we are generated. We are having image, set of images in which one portion of the image get copied, and before pasting we are maybe scaled down, scaled up, or maybe rotated and paste that image itself, and we are saving that image into a JPG format. These are the pre-requirement, or we can say that these are the pre-processing steps to converted image into a forged image. So we have the both side of database, authentic and forged one, and these two issues can be handled if suitable feature of the image can be extracted. Now, in a previous slide, I discussed two methods with you. One is known as block-based method, and second one is known as key point-based method. So first, we need to understand the advantage and disadvantage of these two methods. And what I going to suggest you people, if you want to implement something, please discuss, understand the advantage and disadvantage of the various method, and try to combine the advantage of the different method and try to generate a hybrid one. What I did, whatever advantage of block based and whatever advantage of key point, I merge both of them and create one hybrid method. So first we need to understand the advantage and disadvantage of these two methods. In block based method give a better accuracy and better forgery mapping. Why? It's a very simple reason. Instead of whole image, you are processing one part at a time. That's why the block-based method gives the better forgery mapping. And in an overlapping block, the better forgery mapping ratio is become higher, but at the same time, this process is time consuming and it's failed when the copied region is highly scaled. Highly scaled means you copied the portion and scaled up to the size of the image. So if the copied portion is scaled up to the size of the image, so it is considered like a whole image. So in that case, the block-based methods get failed because every block is similar in that case. So this is the disadvantage of block-based method, and time consuming as well. Why? Because if you consider the overlapping block in a size of 8 by 8, there is a in 8 by 8, 256 block will be generated. And the key point based method, there is no need to divide into a block. This is the less time demanding. This is scale and rotation invariant, means whatever scaling you did, whatever rotation you are providing, it is independent of these two features. It will find an attack on that image, but poor forgery mapping. And one of the biggest disadvantage of the key point based method is that the forgery detection is failed if the region is smooth. What is the meaning of smooth region? I will explain that one. Okay, please try to understand this one. We begin. This is one input image. Background of house, there is a lot of greenery. So that part of the image is considered like a smooth part of the image where the intensity of the pixel is same. So if the intensity of the pixel is same, that is considered like a smooth part. And this is the textured part. The textured part is considered under the category of non-smooth part. So what we did, we apply, first we divide an image into a two, textured part and smooth part. So on textured part, we apply a block-based method, and on smooth part, we apply, on smooth part, we apply block-based method, and on textured part, we apply block-based method, key point-based method. So this is the textured part basically. We are not applying key point-based method on this smooth part. Why? Because on smooth part, the intensity of each pixel is same. So we are not able to identify the correlation between the pixel of that smooth part. That's why the key point method is paid on smooth part. And the same side, we apply the block based method only on smooth part. So what we did, we divide a workload into a two part. The textured part is given to key point based method, and smooth part is given to apply for block based method, and whatever feature is extracted get combined, and on the basis of feature vector we are giving the final result. Here I am discussing some result of this method. Okay, I think this is visible to you, all of you. I think this document is visible to all of you. Vishwasji?
Yes, sir. Yes, sir.
Okay, so the image A is a highly textured image. Image B, this is the smooth part, and this is the textured part, and image C is a pure smooth part. So what I did, I considered the three type of images for our practical, for our operation basically. So what we did, the smooth part in that image is null. So that's why the part is black. In the image B, the smooth part is shown by that blue part. This is because this is the smooth one, and textured part is shown by, because this is not the smooth part, and this is the whole image is get converted into a smooth one. Now, so textured part, and there is a no textured part. And how you people can identify? You people can use the standard deviation filtering. This is one of the method to divide the image into a two part, textured part and smooth part. Why we need to do this operation? We need to apply this operation because we need to apply the block based method on smooth part and key point based method on that textured part. So why? And because that, so key point based method take less time, block based method take larger time. If we average these two, it will take average time. So at the same, and with the efficient result also. Now, these are some input images which we supply to our program, and whatever result we got. So this is the image which is tempered one. What is that attack? What we did, this is the one original part of that image gets pasted here and here itself. So that attack is identified with that red, will identify the attack part. This one is the smooth part. This is the textured part. This is also the textured part, and this is the copy move forgery part is get detected. Similarly, in this one, copy move part is get detected, and similarly in this one, these are the copy move part is get detected. So this is a visual result of the proposed technique on IMD data set. Basically, one more thing, these are various data set are available online. You can, there is no need to create your own data set like CASIA data set, FOMOFO set data set, IMID data set, and etc. Okay. Now, what I did with this method, we provide this type of rotation before pasting, this percentage before scaling before pasting, JPC compression before pasting, and some additive noise before pasting, and our method is still work very well. So these are some example of our input. This is the input image. What I did in this one, copy the part and scale, rotate, pasted in the 60% angle. So both part, this is the original one, this is the copied one. This is the original one, this is the scale one. This is the original one, and this is the scale one. And in the texture image, original and scale, this is the JPC compression one, and this is the noise ratio one. Because noise and compression, we are not able to see the difference, but in the scaling, we can see the difference. This is the simple part, and we scale 200% and pasted here. So it is get detected. And similarly in this one, we are copied here and we are pasted scale in this case. This is the copied and pasted in the scale manner. 50% scale B1 and get detected. And similarly, 60% rotation we provide and detected. So basically, this is the basic idea I am going to give, how you can begin in that field of that image forensic forgery, and very easy to implement one because lots of data set available online and lots of program on GitHub. You can find various research paper. Along with that program, you can find. Just you need to do the practice and provide an alternate, which I already provide in that algorithm. What type of variation you provide in step 1, 2, 3, 4, 5, 6, 7. The different set of algorithm is get generated. Nowadays, okay. Now this one. This is another research field. You maybe try to develop a method to distinguish between a computer generated or photorealistic image from photographic image. Okay. So that top row is a computer graphic generated image, and the bottom row is the picture gallery image. Picture gallery image is captured by the camera. So by seeing, it's very difficult to set that these images are real one or computer graphics one, because most of the time whatever images we received, they may be a computer generated, and whatever advertisement is shown on the website and some there is a clear condition is written that the actual items of color condition may be differ from that picture. Why? Because these pictures are generated through computer. So whenever you receive these items, that not get actual replica of that image basically. So there are lots of methods by applying. You can differentiate between a photorealistic image and the photographic image. And nowadays, the deep learning, the scope, there is a more scope to publish a paper in the field of image forensic along with the deep learning, because whatever algorithm I discuss here. Now, for this algorithm, if you build a model with a deep learning and train a model in such a way whether the image is to be divided into a overlapping and non-overlapping block, that factor is decided by a deep learning method. So this is a new set of algorithm you can generate. Whether transformation is need to apply or not need to be applied, that is decided by a deep learning method or whatever model you train, because you need to design a model, then train the model depending on the requirement, and the new algorithm will be generated for feature vector. So to extract a feature vector method and which we need to arrange, it may be decided by your deep learning model. Either it is to be sorted, whether it is to be get compared, what will be the threshold value. So each and everything need to apply block-based method, need to apply key point-based method. So deep learning method, you can combine the algorithm with a deep learning algorithm, a new set of method get generated, and deep learning method, whatever research work is done till now, what happened, the deep learning and machine learning part is applied at the last, where the model is get trained. Now model is able to identify the image either in forged one or authentic one, forged one and authentic one. But with the help of deep learning method, you can design a model to apply a selection criteria at each and every step. So definitely it will lead to efficiency. Right now we need to decide theoretically whether we need to divide into a block or in key point, whether what type of transformation we need to apply, what threshold we need to choose. But once we design or train a deep learning model, each and everything is designed by the deep learning model, and definitely it will improve the efficiency also. Okay, so that's all from my side, the basic idea for digital image forensic. So now, one more thing, there are some challenges also. These challenges can consider like a new research direction in the field of digital image forensic, because whatever tools are generated, they are not robust. So because we need to design a new foolproof tools. No real comparative study exists which evaluates the actual accuracy of DIF method, because everyone claim their the result based on their data set. Based on their data set, they are not tested on the real data set basically. And one important thing, there is a counter forensic contributes in exposing the limitation of DI tool. The meaning of this line is that just like a forensic, there is a counter forensic field is also created. What people did nowadays, they will hide the traces of the attack of forgery in an image. So it's very difficult to identify the actual attack on an image with the help of conventional method. This happens just because of that counter forensic contribution, which happen in the right now, because our mobile is so intelligent, capture an image in such a way we people are never realize what happened inside that one. So it's very difficult to identify the attack on that particular image. That's a new field in the field of that image forensic. If we can design something to attack over that counter forensic technique, definitely it's a new work. And we need to DIF from another perspective, future challenge digital forensic, the extension of other media, definitely is a video. So video forensic is another field. You can apply the same concept in a video also. In that case, first we convert a video into a set of image, then we apply the set of technique, and we can get the forgery detection in the video also. Okay, so that's from my side. So Vishwasji.
Thank you, sir. Thank you so much for sharing such a beneficial knowledge with us.
Okay, sir.
If anyone have any query, please write your question in chat box.
or my session is not end here. Anyone can get my contact detail from Vishwas sir. For any research direction in the field of image forensic, I will happy to help you. What type, how to write a code, even how to write a simple code to get to detect a forgery in an image. Basically, it's a very simple idea. So anyone can ask anytime. My detail you can collect from Vishwas sir.
Okay, sir. Thank you, sir. If
Okay,
anyone
welcome.
have any question, please write your question in the chat box. Sir, there is one question, one request. Sir, please explain counter forgery again.
Okay. Actually, counter forgery means, suppose what I did, some people copied one portion of image and paste in the image itself. So that's called the copy move forgery attack. What happened due to that copy move forgery attack, where the copied portion get pasted, that portion and copied portion definitely will have the same type of property. Basically, the correlation is higher in these two blocks. Basically, so what counter forensic expert, they try to remove such type of correlation between these two blocks. That's called the counter forensic. In that case, your algorithm is not able to identify that copy move forgery attack. That's called the counter forensic. The counter forensic basically hide the traces of attack. It's happened in the various police cases. The people do the mistake and try to remove that traces, hide the traces, so that no one able to understand something is mishappening is going there, what's going there. It's just like a counter forensic. Counter forensic means hide or remove the traces of attack, so that the who are trying to find the attack is not able to find it.
Okay, thank you, sir.
Okay, welcome.
Now I request our director, Dr. Vivek Bansod, sir, for giving vote of thanks. Over to you, sir. Dr.
Vishwas,
Vivek
I am
Bansod.
audible.
Yes,
I'm
sir, you
audible.
are audible. Yes, sir, you are audible.
My many thanks to Dr. Nilesh Kumar Jain from JP University. A very fruitful webinar and discussion with him. Definitely, this is not, although this is a concluding session, but this is not an end of knowledge as far as cyber security is concerned. A lot of things will be coming more, but this particular webinar was very well conducted by our computer science and IT department. Thanks to the efforts of Vishwas Dikshit ji, head of the department, all the professors, particularly our coordinators, Vishwas Karadkar sir, Vishal Gupta sir, Aniket sir, and all the people who were directly or indirectly connected with this particular webinar. We started on 4th with Padam Shri Dr. Manindra Agrawal from IIT Kanpur. And also on that occasion, we had Dr. Chaube sir, who is a coordinator of RGPV TEQIP 3. And we have been given this particular webinar, although we were running 3 parallel webinars from 4th of this month. One was for mechanical, another was for our basic engineering sciences and communication skill. And similarly, we are having 2 more webinars from our computer science on 8th, 9th, and 10th. The second speaker was Dr. Akhil from Accenture Pune, and he talked about the Spring Cure cyber security. Then we had very well rather I can say fruitful discussion with Dr. Sanjay Silakari ji from UIT RGPV on IoT. Dr. Ravindra Botkar, BNY Mellon, he also come here. Dr. Sandeep Pandloi from Saibej, Pune, he also talked about SAP. So in all, the seminar, or rather webinar, rather I can say, it was very well conducted, and a lot of participants from the different colleges affiliated to RGPV and other colleges also were there. So I'm thankful to all the participants also who have attended this webinar nicely with full enthusiasm. And lot of new things came here, because in our regular syllabus we cannot go into such a deep knowledge, but we had good speakers, the educationalists, the professionals from different fields, and we got the feel of the latest technology in this particular subject, that is the innovative technique in cybersecurity. So again, I am thankful to all the people who were connected with this webinar, as well as the IT sector, that is also very important from our institution, like our PRO, Gautam Chatterjee and his team, our IT cell, they all helped in conducting this webinar. So thank you very much. Thank you. Now over to Vishwas.
Thank you, sir. Thank you so much, all the participants, for giving us your 3 days. After getting your certificate from TEQIP RGP Bhopal, we will send your workshop certificate in your respective mail. Thank you. Thank you so much.